Good morning. This is Mr. Parks from Risen Christ Lutheran School, and I have another video for third grade for Module 4, Lesson 7. In this lesson, we are going to be working with multiplication tables and the patterns we can see on them, as well as I've underlined a part down here for something that I want to talk about to parents. Help you and your student understand what we're doing with these problems, because I still have some students that are struggling with those, so I wanted to include that part. So on the previous page, we would have filled in most of a multiplication table. For this particular problem, we are trying to find out if products are going to be even or odd. So if we choose an even factor, let's say I do the row for 2's and go ahead and circle that, I am going to get all even numbers. And it doesn't matter which row I choose. If I choose 4's, I'm going to get all even numbers. If I choose 6's, I'm going to get all even numbers. I think I will choose this one because we are going to use that on the next page as well. So they're always going to be even numbers unless we do an odd number times an odd number. So to give you an example of what our products would look like if we do an odd number, for one of our factors, we can circle the row for 5's. We are going to start with odd numbers, and then we are going to get even numbers as we end up multiplying by an even number. So 5 times 1, they're both odd, we get an odd product. 5 times 2, one of those numbers is even, so we get an even product, and that pattern will follow as far as our table takes us. Now, on the other side, we are going to be working with the identity property of multiplication. Let me see if I can get this to grab correctly. There we go. So we want any other multiplication fact. Now, we could go ahead and say that we could do 1 times 7, and that would also work. We're just also using the commutative property to help us. But let's say I take that example, we do 5 times 1. We could go ahead and do that. And we could do that for any odd number times 1. Or sorry, not even any odd number. We could do it for any number times 1. So if I wanted to do 100 times 1, that's not going to be on the table, but we could make it work. For number 2 through 6, I'm almost guaranteeing that I will have at least one person that sees this and will not read the directions and forget to underline where it says right, even, or odd. I don't care what the answers are to these. We have them on a table. It'll be okay. But we do want to know if they are odd or even. So if I go here and I find the number 9, I could go ahead and circle that. 9 is going to be an odd number. I'm going to have an even number. I'm just going to abbreviate for this just to save time. Even number for this one because I have 2 even numbers. I have 2 odd numbers here, so I will get an odd number for my product. And I have 1 even number here, so I will get an even number for my product. They want us to finish filling in the row for 6's, so we could actually look at this on the left-hand side of the screen right now. I've already circled that, so I'm not going to take the time to copy that in. What pattern do we see? We do see, again, all even products. And then now for the part that I've had some students still struggling with. So how can we break apart the factors? So this book goes over the distributive property a little bit later than I'd like. And so some of my students are used to just trying to find the final answer without worrying about how to break them apart into easier things. So we want equal add-ins. So the way that we're going to do that is to do 6 times 2 and put that in parentheses plus 6 times 2. And this would be the problem that we could use to find the answer for that. So we would end up with 12 and 12, and then we would get 24 for our answer. And then for the bottom part down here, we are again using the distributive property. So we're taking our larger number usually and breaking that up into 2 smaller numbers that we can add together and then multiply by the other factor. So we're looking to see if we have a pair. We do have a match here. So we're not using the number 6 here. We want to use a number that we can add to 4 that will give us a total of 9. And this part, being in parentheses, should help us figure that out. We are going to get 5 for this one, and for the other one, we need a number that we can add to 2 to end up getting to 8, and that would give us 6. If we saw an example that looked like this, let's say I do 7 times 2 plus blank times 6. This would be an example where we want the other number for our pair. That way we can go ahead and have a match here. I guess I should probably use the word match instead of pair. We can use our match here, and then that gives us the same type of problem. That would be the next step to this problem. So we have different ways that we work with that. So I wanted to remind parents of what that was going to be. So again, if you see something like that on the homework, those are the things we're looking for. We're either trying to figure out how we can add 2 numbers together to get to 8, or we might be also looking to see, oh, this is the number that we need the match for, and that would fill in the blank for this example right here. Hope the video helps. If you have any questions, please feel free to send me an email or text for my Risen Christ students. For the next video, I'm going to be including the homework pages as well. I'm going to see if that is helpful, even if it takes a couple extra minutes to do the video, if that is more helpful than just doing a walkthrough of some of the things that we did in class. Hope you have a great day, and I look forward to seeing you in the next video.